So I'm going to be going over a few questions from the textbook about circuits, and then I chose some for you to practice on. Now, the way that the textbook words their questions is quite a bit different than the way I've been doing it in my lessons to you. So that's mainly why I wanted to show you some examples from the textbook so that you can get used to different kinds of wordings for really the same concepts. All right, so this first one here, number 42, says the circuit in figure 6 has a current of 0.50 milliamps. If V1 equals 4.55 volts and the potential difference across the battery is 12 volts, what are the two resistances R1 and R2? So first of all, language-wise, this term potential difference, that's another way of saying voltage. Okay, so those are kind of interchangeable. So they give you the diagram there, and they tell you some of the information, and they ask you to find some more information. So they tell you the voltage of V1, the current in the circuit, and the voltage of the battery, and they ask you to find out those two resistances. So I want to kind of show you that it can be done the same way as I showed you before, which is by treating it as a circuit puzzle. Okay, so I can make a table where I list all of the items. So that would be the battery, and then that would be two resistors. So I'm going to just call them 1 and 2. Okay, they've labeled it R1 and R2. I'll just label them item 1 and item 2. And then labeling the columns with what I usually do, voltage, resistance, and current. I'm first going to fill out what I know given in the question. So in the question, they tell me the current of 0.50 milliamps, and that would be the current for, well, everything really, because this is a series circuit. There's no junctions for the current to split at. So it's 0.5 milliamps for the whole circuit, but we've got to convert milliamps to amps, and you would do that by dividing by 1,000. So it's 0.00050 amps. Then they tell us V1 is 4.55 volts. So V1 would match with row that I've labeled 1 in the column of voltage. It's 4.55 volts. I was writing negative because it's really a voltage drop across the loads. And then they also tell us that the potential difference or voltage across the battery is 12 volts. So I can write 12 volts for the battery. All right, so that's what they give us. Actually, I'm going to fill out the current. It's the same throughout. That's what they give us, and they ask us to find out R1 and R2. So I'm just going to highlight that in the table here. They ask us to find this box, R1, and they ask us to find this box, R2. Okay, so they don't ask us for the whole entire puzzle. We can stop once we get those two boxes filled out. And so then I think about the tools I can use to try to solve my circuit puzzles, and I can get R1 right away with Ohm's law because I know the other two values in my row for load number 1, so I can get the third value using Ohm's law. So Ohm's law for load 1. So rearranging Ohm's law for resistance, will be voltage divided by current. So that's 4.55 divided by 0.00050. I'll get my calculator up. Giving me 9,100 ohms. So I'll fill that in the table. I'll underline the 2 sig figs there. Okay, and then they also want R2. So I can't get R2 just yet. It looks like first I'll need to find voltage 2. So I can use kVr for that. So then basically my voltage gain of 12 volts must be balanced by the voltage drops in 1 and 2. And I know the voltage drop in 1 is negative 4.55, so that'll allow me to get the voltage drop in load number 2. So I'll just say therefore voltage 2 must equal, okay, so what combined with negative 4.55 makes negative 12? That would be negative 7.45. Okay, that'll make it add up to negative 12. Okay, so now that I have that, now I'm ready to get resistor number 2. Ohm's law again. So that's giving me 14,900 ohms. I'm just going to underline 2 sig figs for that because in my current I was given 2 sig figs. All right, so that's how I would do question 42 from the textbook. Okay, then they get more complicated. So here's number 56. It says in the circuit in figure 13, voltage of the source is 15 volts. Voltage 1 is 9 volts, or I'm going to write negative 9 volts. I3 is 500.0 milliamps, and R2 is 30.0 ohms. And then they ask us to find R3 and I2. So I'm going to do the same sort of thing. I'm going to draw out my table that I normally would for just a regular circuit puzzle. So I have my source, and I've got 3 loads here. So 1, 2, 3. Okay, I'm going to fill out what they tell me. They tell me the voltage of the source is 15 volts. They tell me voltage 1 is 9 volts, which I'm making negative 9 volts. They tell me I3 is 500 milliamps. Once again, have to convert that to amps. So divide 500 by 1,000, and I get 0.5. And they have 4 sig figs there, so I'm going to copy all 4 down. And then they say R2, resistance of load number 2, is 30.0 ohms. All right, so that's what they give us, and I'm supposed to find R3 and I2. So I'm just going to color those in red. These are my targets. So I can stop once I've figured out these targets. All right, so how can I do this here? Well, I think I'm going to start, it looks like I'm going to start with KVR. So I'm going to draw on the diagram here. Voltage at the source is 15 volts. Voltage at the first load is negative 9 volts. So I can use KVR actually. And I will look at the loop that's got load number 2 in it. So it's got 1 and 2. So start at the battery, go up, you will go across load number 1, reach the junction, and then at that junction you get to choose. Do you either go through load 2 or load 3? So I'm focusing on the loop with load 2. So in this loop, I've got a 15 volt gain at the battery, or the source, must be balanced by we got the negative 9 volt drop at load number 1, and another voltage drop at load 2. So I can say therefore voltage 2. So negative 9 plus what else is going to make negative 15 to balance out the 15 from the source. So that would be negative 9 plus negative 6 volts. All right, so voltage 2 has to be negative 6 volts. And voltage 3 would be the same argument, really. So instead of going through the loop with load 2, what if I look at the loop with load 3? The same thing's going to happen. There's going to be a 15 volt gain at the battery, a 9 volt drop at load 1, and then it would have to be another 6 volt drop at load 3. So I'm going to say a similar argument for load 3 results in voltage for load 3 also being negative 6 volts. All right, so I had to do that first before I can actually get the values highlighted in red that are my targets. Now I can get them because looking at my table, in each row, I've got 2 values. So I can get the third value with Ohm's law. So I'll start with load 2. Ohm's law for 2. I have to solve for the current in row 2. So that would be voltage divided by resistance. 6 over 30. That's a nice number, 0.2 to 2 significant figures. And then I can do Ohm's law for load 3. Solving for resistance for that row. So that would be voltage divided by current. So 6 divided by 0.5 to 2 sig figs gives me 12. Okay, so I can stop there because I've answered what the question has asked me to. There's still 4 squares in the circuit puzzle. I could ask you to solve the whole thing, but these questions only ask you to solve for part of them. All right, part B of this question is a little bit different. Part B asks, how long does it take for 20 coulombs of charge to pass through the circuit? How long does it take for 20 coulombs of charge to pass through the circuit? So I'm going to actually have to know the current passing through the whole circuit. So I'm going to need to know the current for the source here. If I'm going to be able to find how much charge passes through. Or sorry, if I'm going to find how long it takes for 20 coulombs of charge to pass through it. Okay, so how do I find out that current? Well, I can use KCR. So I know currents 2 and 3. Okay, currents 2 and 3 are 0.2 amps and 0.5 amps. Well, that came from current 1. Okay, current 1 flows into the junction and it's split up into 0.2 and 0.5 amps. So the current at the source must equal 0.7 amps because we know that whatever it was, it's split up into 0.2 and 0.5. Okay, so that's got to be 0.70 amps. Same thing for the current through load number 1, it's going to be 0.7 amps as well. All right, so I needed to do that actually before I could answer part B. So in part B, I have a current of 0.70 amps. They tell me the charge is 20 coulombs, and I'm looking for how much time that takes. So the formula, and this will be on your formula sheet, also from a lesson a couple of weeks ago, current equals the amount of charge divided by the time. Okay, so that's the formula for part B, and I can rearrange that for time, because it asks us for time. So that'll be Q over I. So that'll be 20 coulombs over 0.7 amps. So 20 over 0.7 is 29 seconds. So that's how you answer a question like part B. All right, I'll show you one more example. This one's a bit of a tougher one. In the circuit in figure 14, R1 is 30 ohms, R2 is 50 ohms, R3 and R4 are 60 ohms each. And then voltage 1 equals 12 volts. Find the total current through the whole circuit and also find the voltage of the source. Okay, so this is a bit more interesting. I'm going to draw my table to start. Voltage, resistance, current, source, and there's 4 loads here. So 1, 2, 3, 4. Okay, I'll write what I know. I know all of the ohms for each of the loads. 30 ohms for R1, 50 ohms R2, and then 60 ohms each for R3 and R4. Okay, and they also tell me voltage 1 is 12 volts, which I'm going to write as negative 12 volts. All right, so they ask me for 2 things, part A and part B. Part A asked me for the total current through the circuit. So the total current refers to the current through the battery, the source. They also asked me for, in part B, V source, voltage of the source. So these 2 boxes in red are our goals for this question. All right, how can I analyze this? Well, I can get the current through load number 1. Okay, yeah, I can get the current through load number 1 because looking at that row in the table, I know 2 values, so I can get the third value. So I will say Ohm's law for 1. Current is voltage over resistance. So it's 12 over 30. That's 0.4, I believe. It's mental math. Okay, so there's a current through load number 1. And looking at the diagram, load number 1 and load number 2 are in the same pathway. So whatever the current was through load 1, it's going to keep going and be the same current as load 2. So KCR, there are no junctions. Between loads 1 and 2. So they have the same current. So that means I2 is also 0.40 amps. Okay, so now that I've filled that in, I can complete row 2 and find the voltage of row 2 with Ohm's law. So Ohm's law for voltage is resistance times current. So for row 2, I got 50 amps times 0.4. Sorry, 50 ohms times 0.4 amps. That would be 20 volts, which I will write as negative 20 volts. All right, and that allows me to get V source. Okay, that allows me to get V source. So that would be KVR, key across voltage rule. The voltage at the source is balanced by, so I'm looking at the top loop here, the top loop. At the top loop, whatever the voltage gain at the source is going to be balanced by the 2 voltage drops at loads 1 and 2. Which are negative 12 volts and negative 20 volts. So therefore, combining those two, that's negative 32 volts. That means the voltage at the source is 32 volts. All right, so there's my answer to that. That's part B. So part A, I need the current. For the source. So there's a couple of ways I can approach this. One way, I could find the equivalent resistance, because since I know the resistances of all the resistors, I can find the equivalent resistance and fill in the top square for resistance, and then get my current. Second method would be getting the voltages for resistors 3 and 4, and then getting the currents for that, and then using KCR to find the current. So you know what? I'm going to do both ways, and hopefully the answer will be the same. I'm kind of running out of space. I'm going to try to shrink some stuff here. Okay. I'm going to start by finding the equivalent resistance. REQ. Okay, so to find the equivalent resistance, so here's a circuit I have. I basically have a split okay, so there's my circuit with 30 ohms, 50 ohms, and then the other two are 60 ohms. So what I'm going to do is combine the 30 and 50 ohms, because those are in series, to make 80 ohms. And then the other pathway, the 60 and 60, can combine to make 120. Okay, so this turns into a simpler circuit where it's an 80 ohm resistor parallel to a 120 ohm resistor. Okay, so that was the first step. And then the 80 and 120 are in parallel. So then the equivalent resistance can be found as follows. Use the formula for parallel. Okay, so 1 over the equivalent resistance will equal to 1 over 80 plus 1 over 120. The common denominator for 80 and 120 would be 240. Okay, they both go into 240 evenly. So that's going to be 3 over 240 and 2 over 240, which is 5 over 240. And then take the reciprocal of both sides. It'll be 240 over 5, which is 48 ohms. Okay, so I can write 48 ohms in for the equivalent resistance. And that'll allow me to find the total current. So the current would be 32 volts over 48 ohms, which is, that's 2/3 exactly, actually. So that would be 0.66 repeated, or rounded to 0.67 amps. All right, so that's how I got the answer with one method, 0.67 amps. I'm going to use the other method. Hopefully, it'll give me the same answer. So I'll make a little box here where I'll do another method here. Okay, looking at KVR again, this time for the bottom loop. Here's a new concept. The 32 volt gain at the battery needs to be balanced by 2 voltage drops at loads 3 and 4 for the bottom loop. Okay, 32 volts must be balanced by voltages 3 and 4. However, I know that they're going to be the same voltage, 16 volts each, because they're the same resistance. All right, so I'm going to say since 3 and 4 have the same resistance and the same current, it's important that it's both that are the same. So they have the same resistance because it says they're both 60 ohms each. And they have the same current because they're in the same pathway. Okay, there's no junctions between them. So since they have the same resistance and the same current, they must have the same voltage. Because of Ohm's law, voltage is resistance times current. Okay, so resistors 3 and 4 have to have the same voltage, and they have to add up to negative 32 volts. So that means they're negative 16 volts each. Okay, knowing those voltages allows me to calculate the current. I'll just do it off to the side here. So Ohm's law for resistor 3. I'll just do it for resistor 3. Well, and 4, they're the same values. Current is voltage over resistance. So 16 over 60, which is 0.26 repeated, so 0.27 when rounded. And that is a good value. That matches what I got before. Because now, look, when you add the two currents of the two pathways together, 0.4 and 0.27, you get 0.67, which is the same current I calculated using the equivalent resistance method. All right, so this was a long video, but I did solve 3 problems, and the last one in multiple ways. And hopefully I talked about enough details for you to try to complete the other practice questions from the textbook.